Hello everyone. So today we are working on a project which is adaptive engagement intelligence platform. So the basic of this project is to find us to give the statistics dashboard of the person or the users, how many people have been coming in the e-commerce website area. So let me showcase the project here. In this case, if you see the adaptive engagement, we have data, we have raw JSON file in which is generated the unstructured data with that output going, and these are the output models which is we have taken. In this, the more main the models which are acting as anomaly detector and a tune predictor. In anomaly it is unsupervised and this is supervised. Basically we are using two models which is supervised and unsupervised. So coming to the dashboard, this is the stimulate we have used for the UI design, and the results are these all basically here in this all with the data. Let me showcase you how we have started from generating it and further. So, okay, so basically here you see imports are there, and we have been going with others by adding all in generator, view product, click, and here you can give for users 500, 300 per products which we have given here, and for events 10,000 or 1 lakh. Event types also here we have given by going with the continuing it, view product one at least and all. So here we are saving the path by the way in JSON log area, which is as unstructured data, and further we are using the personas here we are giving for window shopper or anything, and here's the main for generating the like data and all timestamp everything here for window shopper what to add and all. You can go further for the code, and then it is the whole generating logs where we have converted into JSON, which is an unstructured file, and then we are going with the parser. So here basically parser is making the unstructured data set to the structured, which is user segment we have given, which is a structured data set. So here you can see the user ID, total session, everything we have given as much we have generated, and it has been made into a structured data set. This is what it does. And for the next we can go is the features one could be. So in our features, as you see, we have been going the as I told you, the structured data set which we have made it, we have converted to parcel, that we have kept it, and here we have gave a path which it makes a new feature as what we have added in it. So in this feature, we have added user ID, session ID, timestamp, and all, etc. Add to cart, everything, whatever required and all. So this is what features. It's basically adding extra. Then we are going with the segmentation, which is a clustering one. So basically here we have used the clusters to cluster similar data set, and it's the work to make it the data set data more easy, make it similar kind of. So this is where segmentation works, and this is the whole code of the segment. Then we go with the tune prediction, which is the main thing, which is supervised model technically. And in tune prediction, we can show you here the uh, random forest we have taken it as here. So here we are seeing the 10 models, we are comparing it and we are working on it. But we have here we have chosen is the random forest technically, because that's the best model, and we have worked on before also, and it gives good prediction even. And here three models which has given random forest and decision tree logistic regression has 100% accuracy, but we went with the random forest as it's more trustable and to work on. So now we are going with the anomaly detection, which is unsupervised model. Here before we have went with the isolation model, forest isolation forest model, but it couldn't. So now HMM learn model, which we have worked on. So HMM basically is the is basically here the you can see it's HMM learn model typing in it, and it is basically hidden Markov's models. So it is an unsupervised learning model, and here we have given with this as the Skylight API and all whatever. So this is the unsupervised learning model technique. This model is good at detecting the patterns and all. So we have given as HMM model we go with it for the user ID or for the sequences length also present over it and grouping in it. So this is basically the model works it, and then the retention strategy. So here, what it does is it compares the models like for the supervised and unsupervised both it does be. So by taking the path and output one here, you see the path and the output. So we have taken for the comparison, being like it's kind of mixing both and to showcase unsupervised with supervised. This is what retention and to showcase like urgent incentive behavior. If any problem occurs, like detection, basically it works out as. So this is what retention anomaly works out here, being in it. Now coming to the dashboard, which is the final and the main, not main exactly, but better one to make understand a user or an developer, AML developer. At here by we'll write a code cd adaptive which we are accessing by tab, and then we are going with the to showcase directly the streamlit here Python streamlit my dash m and giving the right name, but we'll return we have ran for the dashboard, so you can check here by entering it. The Chrome site it will open, and it's taking time basically because Streamlit takes time to process it and showcase. So here it's running as it's being running. If running is not shown, so basically there's an error, and it will show directly on the error method and the image Streamlit in there itself by saying the module number and the lines you can see in it. So it's still running as it's taking lot time. Now it's gonna come. Okay, so here you can see uh, over as you can see on my left side, user onboarding is there, and adaptive engagement, that which are user onboarding. In that we can give user ID, saying like maybe Abhi, and any age group you can give from 18 to 60. So here randomly I'll choose 22, and then in gender obviously male. In location there are many locations, but it's not like any other also we can add up. There's nothing in it. So we are submitting user info here. User Abhi is onboarded. Then here in this browse interact with products, you can see there are to choose products here. Basically, it is like apples and other more ingredients we can add in it. So we can here first is going to be viewing the details. So milk details will be viewed, and here what happens in the event log, as much whatever you're doing, watching or doing any clicks, is being stored, and the interaction log is basically the data set. You can download the data set. So here we can add to cart and then check out, and we are going with a confirm purchase. We will go with confirm purchase, and here we brought, so here whatever we have done from the starting, view product, add to cart, then checkout, then purchase success. So and the time set you can see and date whenever you have done it. Now Abhi one I'm giving extra one, and any age similar case we are going with the same. So instead of view product details, we'll go directly add to cart, then checkout, or instead of checkout, we could go with adding some other products like bread, and checkout we do it, but we are not gonna buy this time. The confirm purchase, we are not buying. So we are leaving it. And now example, we are changing the username to something like Ishani. So it's a female name, so we are adding female, and any location. And here you can see she wants maybe bread. We instead of viewing product, you can add directly, and then rice also. And then we are checking out. That's it. So here you can see the event log and the product interaction log, even in that all details whole. You can download the file also. And here anomalous user detection, which is Abhi one. You remember it has come to the checkout list, but haven't confirm purchase. So this is then like no pattern, like it's not a good pattern, this behavioral pattern, so it's being recognized. So here in the detection it's been, now we are going here, three people have onboarded, so we are running the clusters. In the clusters you can see the similar data set type which we have used k-means here, and you can see the cluster data is running technically, and then the graph plot also comes out. Here it shows the graph plot, the whole graph plot showing three users, what they have done, when, how. If it would be more 100, then it would be better to showcase like more 100 users. It can take multiple users, their dot could be shown. And this is the user distribution by cluster. You can see here the pie chart basically, so that makes easy to understand where and how people have kept it. And then going with the GitHub, we have kept here whole code. everything, the from the requirement, from the generate to the dashboard, everything including here. So yeah, and here we have git ignore. We have used a file removing JSON, CSV, and PKL files so that you could generate yourself your own and any model if you want, going with adding. And here this is the steps how to go from the starting, from going with generate, parser, segmentation, features, and all to showcase any model you can use. It's not like random forest is compulsory. You can go with LSTM if you want, but it's up to you whichever model you want to choose. So yeah, this is what whole overall is. So it's yeah. So thank you.